Data structures and algorithms. We can look as separate topics. First data structures, then we can move to the algorithms. Data structures are the raw material used to build software applications. Data structures can be divided into two parts such as built-in and user-defined data structures. You can see few types here, from both categories. Built-in data structures are list, tuple, and dictionary. User-defined data structures are stack, queue, linked list, tree, graph, hash table and heap. You can go through this and follow table to understand the features. Now you will learn the Python codes for the data structures. By using append, we can add elements to the list. By using remove, we can delete the elements from the list. In tuples, we can't modify the elements time to time. In a set, we can add element by using add keyword and delete elements using remove keyword. In dictionary, there is a key and value. For stack, we can use append to add elements and pop for remove the elements. In queue also we can use append to add and pop left to remove the elements. This Python code defines a linked list using two classes as node and linked list. The node class creates a single unit of list, storing data and a pointer called next to the next node. The linked list class manages these nodes. It starts with an empty head called none. The append method adds new nodes to the end of the list. If there's no head, the new node becomes the head. Otherwise, it loops through existing nodes until it finds the last one and links the new node to it. The display method prints all node values in sequence, using arrows to show the connections, and ends with none to indicate the list's end. In the example, nodes with data A, B, and C has been added. This code defines a simple tree node class called node, which stores a value in data, and keeps a list of its children in children. The add_child method appends a child node to that list. In the example, a root node and two child nodes are created. Both children are attached to the root using root.add_child. Finally, the code prints the root's value followed by a list of its children's values, showing the immediate structure as in the slide. This represents a graph using a Python dictionary, where each key is a node, and its value is a list of nodes it's connected to. For example, node A is connected to B and C, so when you print graph A, it shows B, C. This is known as an adjacency list representation of a graph. This is a hash table, which stores data as key value pairs. Here, student IDs 101, 102 are keys, and names Nimal, Kamal are values. When you access students 101, Python uses hashing to instantly find the value Nimal. It's very fast for lookup, insert, and delete operations. A heap is a special binary tree structure used for efficiently finding the smallest or largest element. Heap queue. Heapify nums converts the list into a min-heap, meaning the smallest number always stays at the top. Heap queue. Heap pop nums removes and returns that smallest value here, 1. Heaps are often used in priority queues or sorting algorithms. Thank you for watching. Keep in touch for more knowledge.